Hey, what's up, guys? It's day 20. Today we're going to take a look at some inverse trig derivatives, and we're going to continue to look at the chain rule, and we're going to look at the chain rule with respect to inverse trig derivatives. So the first thing is, I'm just going to define for you the inverse trig, so inverse sine, inverse cos, inverse tan, or also called arcsine, arccos, arctan. I'm going to define those derivatives for you. I just want you to have them in your notes. Later on, when we learn implicit differentiation, we're going to be able to prove these things, but I want to get them out there first so we can practice them with the chain rule. So, first, is the derivative of the arcsine of x. Now, this notation is not my favorite notation because usually when we write a little exponent in between the sine or the trig function and x, it means sine of x to that power. That's always true except for in this case. The inverse sine of x always means, when we use that notation, that always means the arcsine of x. The AP test sometimes uses the -1 notation, sometimes uses the arc in front of the sign notation. Either way, they're talking about the same thing. So we just want to understand that we do this derivative not by how we do sine squared x. Okay, this is not a chain rule problem. This is simply a derivative that we need to memorize. So the answer is so the derivative of arcsine of x is 1 over the square root of 1 minus x squared. Again, if you've been making note cards, this would be a good one to put on there. They don't test this concept a ton on the test, but they show up every once in a while, and it's just nice to be able to get that point. We also have the derivative of the arc cosine of x. That is the exact same as the derivative of sine, except for the fact that it has it's negative, so it's -1. So they look almost identical, except for the derivative of arc cos is -1 over square root of 1 minus x squared. Tangent always likes to be different, so let's look at tangent. So the derivative of arctangent, notice the differences. There is no square root here. It's simply 1 over 1 plus x squared. Also, instead of always being minus, this one is a plus derivative. Again, this will all make sense where we get these from when we look at implicit differentiation, but for now, start committing these to memory. They're not as important as the derivative of sine, cosine, and tangent, but they still can show up on the test, and it's nice to get them right. Sometimes where I see these on the test is they test this with the chain rule. So let me show you an example of a problem that you might see. So we see this, and now this is a chain rule problem, right? We see that we're doing the arctangent of, not x, but 5x squared. Well, all the stuff we learned about the chain rule is still going to apply here. We want to do the derivative of the outside with respect to the inside times the derivative of the inside. So maybe pause it here, take a guess. What do you think is going to happen here? And then unpause it when you're done trying to see how we do this. Okay, we're back. I'm going to use the framework for the derivative of arctangent of x to solve this. Our inner function here is 5x squared. Our outer function is the arctan of x. So we do the derivative of arctangent, but instead of it being with respect to x, right, look, scroll up here for a second, it's not going to be 1 over 1 plus x squared. It's going to be 1 over 1 plus 5x squared squared. So it's going to look like this. Again, we're doing the derivative of the outside with respect to the inside. But as we know, that is not the end of the chain rule. The derivative of the outside with respect to the inside is the first part, but we got to chain on our derivative of our inside. So we have to multiply this thing by the derivative of 5x squared, which is 10x. Cleaning this up, we can see it looks like this. And there we have it. Our first arctan derivative mixed with the chain rule. Again, some people might think, oh, let's cancel out some x's here. We can simplify this more. Because there's no x in that term on the in the denominator, the 1. We can't cancel the x's. We got to leave it as is. Let's try one more. So let's say g of x equals the arcsine of 4 minus 5x. We want to go ahead and find g prime here. X. Go ahead and pause the video. Now that you see how to do the arctangent one with the chain rule, try this one on your own. All right, we're back. Here's what we're going to have. We're using, again, our inner function here is 4x minus 5. This is our inner function. Our outer function is the arcsine. So we want to do the derivative of the outside with respect to the inside. And then we have to multiply by the derivative of the inside. Well, what's the derivative of 4 minus 5x? Well, we know the derivative of 4 is 0. The derivative of negative 5x is negative 5. A lot of times people put 5 as the answer here, but we have to see that, oh no, it's negative 5. We need to multiply by negative 5. Now, generally, when we simplify this, we're just going to put negative 5 on top, and we'll have square root of 1 minus 4 minus 5x squared. Most of the time, when it's a binomial squared, they just leave it in that factored form. They don't FOIL that whole thing out. If we needed to, we could. Whereas in the previous problem, 5x squared, they would simplify that to 25x to the 4th. So this is as simplified as they usually leave it. I want to look at one more problem here. Why don't you go ahead and just pause the video here, and I want you to copy this graph and this table into your notes so we can reference it and use it. So pause it here and put that down. Okay, we're back. What I want to do now, here we have a graph of G. G is made up of line segments, as we can see in this video here. And we have a function f that we have table values of. What I'm going to do is I want to define a new function. So I'm going to say the function h of x equals, let's do g of f of x. So h of x equals g of f of x. And I want to find, let's do h prime of negative 2. So we want to find h prime of negative 2. Now, I've been harping on you guys about this all week, about before you do h prime of negative 2, what do you need to do h prime of? What does the grader need to see in your notes? Well, they're going to really want to see h prime of x first. We want to start with h prime of x. Go ahead and pause it here and find h prime of x on your own. And if you want to, solve it all the way out to h prime of negative 2. Okay, so h prime of x has to be, we need to use the chain rule here because we see a function, f of x, within another function, g. Chain rule is very simple. We do the derivative of the outer function with respect to the inner function times the derivative of the inner function. We're going to get usually that earns you a point on the test. Now we just have to plug in and figure this thing out. So let's go ahead and do h prime of negative 2. Well, I'm just going to replace all my x's with negative 2's. Now I can start solving this thing on my way down here. So this is going to equal h prime of negative 2. It's going to equal g prime of, I need to figure out what f of negative 2 is. Well, I go up here to my chart. When x is negative 2, f of negative 2 is 3. I can also figure out f prime of negative 2 by looking at the chart. F prime of negative 2 is negative 1. Make sure when you guys are using tables like this, make sure that you are very, very careful and get all the correct values in there. We don't accidentally overlook something. Okay, so now this problem relies on my ability to find g prime of 3. Let's look up to the table, or look up to the graph, I mean. And I want to find g prime of 3. The question is, am I looking for the y value on this graph at 3, or am I looking for the slope of this graph at x equals 3? Well, again, we're looking for g prime, right? G prime of 3. This is telling me the slope of the line. So I want to know, what is the slope of the line right here? Now, there's a million different ways to calculate slope. On graphs, I like to just think of it as rise over run. So I look at that line segment there, and you do this in yellow. We rise 1 and run 4. Notice I was moving both up and right, so those are both positive numbers. So my slope here is 1, 4. And I'm taking that 1/4 and I'm multiplying by negative 1, so I end up with an answer of negative 1, 4. Right? That is h prime of negative 2. That is it for today. We're going to start our review process, and we will probably be testing on this chain rule and product rule and quotient rule next week. So it might be a good idea to rewatch the product rule, the quotient rule, and the chain rule videos just to be very, very comfortable, so we're ready to do really well next week. Have a great weekend. See you on Monday. 2 chains. Outro. I don't really know what an outro is, but 2 chains.